Good. This is Jeffrey Baker at Lone Star College North Terrace. Today's date is March 4th, 2026. So in today's video, or today in the lab, this is going to be another lab video. So we're studying the deceleration of actuators. What I'm going to do in this video is show you the schematic of this actual pneumatics section, this part, so with all of these and the airlines. And then I'm also going to show you the ladder logic diagram. That's going to be explaining the electrical portion of it. Okay? And then after I show you those, I'm going to actually just show you the functionality of the system. So to start off, I'll show you this first schematic. So right here I'm going to identify a few things. This is the inlet of air. There's two. So it goes into this directional control valve 1 with one solenoid on it. Okay. It goes over, it can go two different ways. But you go over here, this is a flow control valve right here, flow control valve 2, and also has a check valve in it. Okay. So it's going to bypass that. Go up, it can take two directions. So if you want to just go all the way up, this is flow control valve 1, so it can also bypass that. And there's another flow control valve right here in the middle. This is another directional control valve, but it has two solenoids on it. Okay. Also, that's where this inlet comes in. This air pressure comes into this one. Okay. From there, this is a directional control valve as well, but these have piloted ports right here. So these air control the positions right here. Okay. And I've also got this cylinder and rod. So this is double acting cylinder. You can tell by that symbol. Okay. So limit switch 1, limit switch 2, and then proximity sensor 1. So that is the schematic for all of the air portion, and then the pneumatics portion. So this right here is a ladder logic diagram. Over here you've got 24 volts. This is the power side. This is the negative, so positive and negative, right? And then all of these in between are connections. So we got one going to the proximity sensor, and then that goes out to a CR1, the control relay 1. You got a limit switch right here, control relay 2, another limit switch, control relay 3. So you've got control relay 2. It's going to branch off of this one. So that's what this is normally open. Then you got the push button that's normally open. You've got another branch right here, control relay 4, that's normally open. Okay, over here, normally closed, CR3, and then this is the actual CR4 main part. Okay, all of these normally open, CR5. These right here are solenoids down here, and these are also controlled by these control relays. Okay, so now I'm actually just going to show you the functionality of it. So what's going to happen is, this is the cylinder and rod right here. This right here. This rod is going to extend, but then decelerate and slow down before it hits this limit switch. Right? So you don't want it to extend all the way completely fast because it's too much force. It can be too much force. So you want to slow down before you get there to have a more controlled system. So to start up, I'm going to turn on this startup valve right here. This is our manifold direction control valve with one solenoid, direction control valve with two solenoids. This right here is another direction control valve, but it's piloted right here by these. We got our full control valves, all these right here. Okay. And then proximity sensor, these are both limit switches. So I'm going to go ahead and turn on the startup valve. Now I'm going to turn on the electronics. And then as soon as I press this button, it's going to extend and then slow down before it hits that, and then retract at full speed. So I can increase how much it slows down before it gets to that limit switch by changing this flow control valve. So see, it dramatically slows down, hits it, and then retracts at full speed. So one more time, push this button, slows down, retracts.